As space exploration continues to captivate the imagination of people around the world, the idea of sending humans to Mars has become an increasingly popular topic. Welcome viewers to the video where we'll be discussing the race to Mars between NASA and China. In the last few decades, Mars has been the focus of various space missions, with rovers exploring its surface and gathering valuable information about the planet's geology, atmosphere, and potential for supporting life. However, the next big milestone in space exploration is to send humans to Mars, and NASA and China are leading the charge. In this video, we will explore the details of NASA's and China's plans to send the first crewed missions to Mars in the coming decade. We will discuss the challenges that come with such a mission, including the physical and psychological toll on astronauts, the technology required to travel to and land on Mars, and the potential risks and rewards of such a mission. So, buckle up and get ready to learn more about the exciting and ambitious race to Mars between NASA and China. As we all know, sending missions to Mars is no easy feat, the reason being, the distance between Earth and Mars is ever-changing. The two planets orbit around the Sun at different speeds, which means that the distance between them can vary from 34 million to 250 million miles. This variation in distance makes it challenging to send missions to Mars. Launch opportunities are limited to a specific window when the two planets are at their closest. This window comes every 2 years, and it lasts only a few weeks. If a spacecraft misses this launch window, it could mean a delay of up to 2 years before the next opportunity arises. NASA and China are well aware of these challenges and have been working hard to overcome them. Both space agencies are planning to send the first crewed missions to Mars in the coming decade. NASA's plan is to send humans to the Red Planet by the 2030s, while China aims to achieve this goal by the end of the decade. NASA's first mission to Mars, the Mars InSight lander, was launched in 2018 and successfully landed on the planet's surface in November of that year. It was followed by the Mars 2020 mission, which included the Perseverance rover and the Ingenuity helicopter. The Perseverance rover's primary objective is to search for signs of ancient microbial life on Mars, while the Ingenuity helicopter's goal is to demonstrate that powered flight is possible in the planet's thin atmosphere. China, on the other hand, launched its first Mars mission, Tianwen-1, in July 2020. The mission included an orbiter, a lander, and a rover, and its primary goal is to search for signs of water and evidence of past life on Mars. With both NASA and China working tirelessly to achieve their goals, it is only a matter of time before we see humans setting foot on the Red Planet. The future of space exploration is indeed exciting, and we cannot wait to see what lies ahead. Conventional propulsion methods have been used in the past for missions to Mars. These methods take between 6 to 9 months to travel between Earth and Mars, which means that round-trip missions could take up to 3 years. This is mainly because the distance between Earth and Mars varies depending on their relative position in their orbits around the Sun. The article highlights that the launch opportunities for missions to Mars are limited due to the varying distances between the two planets. A launch window opens every 26 months when Earth and Mars are in optimal alignment, which allows for a shorter travel time. However, this window lasts only a few weeks, which means that any delay in launch could result in the mission being postponed for another 26 months. Conventional propulsion methods such as chemical rockets have been the primary means of transport for missions to Mars. However, with the longer travel time, astronauts are subjected to prolonged exposure to space radiation, which could have adverse effects on their health. Additionally, carrying all the necessary supplies for the mission, including food, water, and fuel, for such an extended period increases the weight of the spacecraft, making it more challenging to launch. Therefore, scientists and researchers have been exploring new propulsion methods that could reduce travel time and improve the safety and efficiency of missions to Mars. While conventional propulsion methods have limitations in terms of time and distance, a recent study by NASA's Jet Propulsion Laboratory, JPL, has proposed a new idea for a crewed mission to Mars. The proposed mission would involve launching a crewed orbital mission to Mars in 2033 that would last just 1.6 years. This would be accomplished by taking advantage of a phenomenon called Mars-Earth synchronization, which occurs once every 26 months. During this window, the distance between Earth and Mars is at its shortest, making it easier and more fuel-efficient to launch a mission. According to the study, the proposed mission would involve a crew of 4 astronauts traveling to Mars in a spacecraft equipped with advanced propulsion technology. This technology would use a combination of electric and chemical propulsion systems to increase the spacecraft's speed and reduce the travel time to Mars. Once the crew arrives in Mars orbit, they would spend approximately 1 year studying the planet and its moons before returning to Earth. This proposed mission represents a significant improvement over current Mars mission designs, which can take up to 3 years to complete. By reducing the travel time and mission duration, the proposed mission would help mitigate the risks and challenges associated with long-duration spaceflight, such as bone and muscle loss, radiation exposure, and mental health issues. Moreover, this mission would also pave the way for future crewed missions to Mars, helping to establish a sustainable human presence on the red planet. During the opposition, Mars and Earth come closest together, making it the optimal time to launch a mission to the red planet. This unique alignment reduces the travel time to just 7 months, compared to the usual 6 to 9 months. This allows for a crewed mission to Mars with a shorter duration of 1.6 years, reducing the risks and challenges associated with a longer mission. NASA's JPL is proposing to take advantage of this opportunity by launching a crewed orbital mission to Mars in 2033. The mission would involve sending a spacecraft to orbit around Mars and study its environment, including its atmosphere, geology, and potential for human exploration. This could provide valuable information for future missions to Mars and help pave the way for human colonization of the planet. While the proposed 2033 mission presents a unique opportunity, it is not without its challenges. Current mission architectures and technologies carry risks that must be addressed to ensure the safety and success of the mission. One significant challenge is the development of long-duration life support systems, LSS, capable of sustaining a crew for 1.6 years in deep space. The crew will need food, water, and oxygen, as well as a means of managing waste and carbon dioxide. Another challenge is the use of solar electric propulsion, SEP, for the mission. While SEP is more efficient and can save weight, it requires large solar arrays and has lower thrust than traditional chemical propulsion systems. The mission also relies on zero boil-off, ZBO, cryogenic propellants, which have never been used in a deep space mission. ZBO propellants are essential for reducing the weight of the spacecraft, but the technology is still being developed and must be thoroughly tested before being deployed. Finally, the mission will rely on liquid oxygen, LOX, produced on Mars for the return journey. While this technology has been tested on a small scale, it has never been implemented on a mission of this scale. If successful, it could significantly reduce the cost and complexity of future Mars missions, but the risks associated with the technology must be carefully managed. Overall, the success of the 2033 mission will depend on the ability of NASA and its partners to address these challenges and develop new technologies to ensure the safety and success of the mission. The Deep Space Transport, DST, is an essential component of the proposed mission to Mars. It would serve as the transportation vehicle for the crew and act as a base for the exploration of the Martian surface. However, the DST poses significant challenges and risks to the mission. One of the most significant challenges is the design and construction of the DST itself. It would need to be durable, reliable, and capable of providing the crew with the necessary resources for the duration of the mission. This includes life support systems, power generation, communication equipment, and more. Another significant challenge is the health and safety of the crew. The long-duration mission would expose them to various risks, including radiation exposure, psychological stress, and physical strain. The crew would need to be adequately trained and prepared to handle these risks and any potential emergencies. Moreover, the DST's propulsion system would also pose a challenge, as it would need to be capable of providing the necessary thrust to transport the crew to Mars and back safely. This requires a robust and reliable propulsion system that can operate over extended periods. In summary, the deep space transport poses several challenges and risks to the proposed mission to Mars. Addressing these challenges would require significant investments in technology development, testing, and personnel training. Nevertheless, NASA and other space agencies remain committed to achieving crewed missions to Mars and unlocking the mysteries of the red planet. Nuclear propulsion and in-situ resource utilization, ISRU, are two promising technologies that could help to reduce the risks and challenges associated with crewed missions to Mars. Nuclear propulsion could greatly reduce the travel time between Earth and Mars, allowing for quicker and more efficient missions. ISRU, on the other hand, would enable astronauts to produce the resources they need for survival on Mars, such as water, oxygen, and rocket propellant, using local resources. However, the development of these technologies poses significant challenges and risks. Nuclear propulsion requires the development of advanced nuclear reactors that are safe and reliable, as well as the establishment of protocols for handling nuclear materials in space. ISRU requires the development of equipment and processes for extracting and processing resources on Mars, as well as the establishment of a sustainable infrastructure for resource utilization. Despite these challenges, the potential benefits of nuclear propulsion and ISRU make them compelling options for future crewed missions to Mars. Continued research and development will be needed to overcome the technical and logistical obstacles and make these technologies a reality for space exploration. The proposed mission architecture aims to avoid higher-risk technologies and minimize the number of new vehicles and developments required. The crew would travel to Mars in the Orion spacecraft and then dock with the Mars Transit Vehicle, MTV, a reusable vehicle based on existing technology. The MTV would use solar electric propulsion and would be pre-deployed at Mars before the crew arrives. Additionally, the MTV would be capable of transporting the crew back to Earth, eliminating the need for a separate landing vehicle. By utilizing existing technologies in vehicles, the mission architecture significantly reduces the risks and uncertainties associated with developing new technologies for the mission. Thank you for joining me in this video where we discuss the exciting prospect of a crewed orbital mission to Mars in 2033. We learned about the limitations of current propulsion methods and the risks associated with current mission architectures and technologies. However, the proposed mission architecture avoids higher-risk technologies and minimizes the number of new vehicles and developments required. Moreover, 2033 presents a unique opportunity due to a Mars opposition, which only occurs once every 26 months. This mission has the potential to yield groundbreaking scientific discoveries and pave the way for future missions to the Red Planet. As we look towards the future of space exploration, it's important to consider the possibilities that advancements in technology and innovative mission architectures can bring. I encourage you to leave your thoughts and comments below and join the conversation about the future of space exploration. Thank you for watching, and may the spirit of exploration and discovery continue to inspire us all.